I am Kamal Bhatia, Assistant Professor, ABES Engineering College, Ghaziabad. This is the lecture series for the subject Network Analysis and Synthesis, and we are covering unit number 1, that is Fundamental of Network Analysis. So in unit number 1, there are 5 topics: nodal analysis, mesh analysis, duality, source transformation approach, and the matrix approach. Today we are going to understand what is mesh analysis. So let's talk about what is mesh. Mesh is a loop which does not contain any inner loop. So this is the basic definition of the mesh. Mesh is a loop which does not contain any inner loop. Also, mesh analysis can be only applied for the planar network. So if we want to find the current or voltage across any resistance in the circuit, we can use the mesh analysis. So first of all, let's talk about what is mesh. So we have discussed just now that basic definition of mesh, and take the example. I'm taking this example starting from this 20 volt, coming back to this 20 volt again. So this is particular, only one loop is there. Also one mesh. So if I talk about the counting of mesh in this particular figure number 1, so only one mesh is there. Let's talk about the second circuit. There are two mesh. This is mesh number 1. You can see this is mesh number 2. So as per our definition, mesh is a loop which does not contain any inner loop. So taking third example, this circuit, there are 3 mesh. You can check. This is first mesh. This is second mesh. We can write it as, and this is third one. So in this particular circuit, one mesh, then two meshes, then three mesh. So this is the basic method of counting the mesh. Now, how to solve any circuit using mesh analysis? So let's talk about the procedure. First point, identify the total number of mesh in the circuit. So first of all, we need to count the total number of mesh in the circuit. That is, if I talk about this circuit, only one mesh is there. So you have to count the total number of mesh. Assign the current direction for each mesh. Just now I have put here the mark, the direction of current. You can write the direction of current opposite also. I have taken the clockwise direction. One can take the anti-clockwise direction also. And we need to adjust all the other parameters according to that. Third point is develop the KVL equation, Kirchhoff voltage law, for each mesh. Suppose in this question, in this circuit, there will be two mesh. So we need to write the KVL equation for each mesh. And the fourth point is by solving the KVL equation, mesh current, whatever, how many mesh means first, in the first circuit, there is only one mesh. So one current can be find out or can be identified. In this particular circuit, two currents, two mesh current can be identified. So this is the procedure, simple. We need to follow the procedure for mesh analysis. Let's take an example. Read the statement of the question. Calculate the current across all the resistances. So there are 10 ohm resistances, 40 ohm resistance in this circuit. So let's talk about how many mesh are there. We have to solve this question using mesh analysis. So only there is one mesh. Assign the direction of current. I'm writing it as I1. So I1 current is also mentioned in this circuit diagram. The direction of I1 is given. So I need to write the KVL equation. Apply KVL equation in one mesh. Apply KVL equation in the one mesh. So because only one mesh is there in this question. So while applying KVL, one thing you need to remember that you should know the polarity. Likewise, this is plus, this is minus, this is plus, this is minus. Again, plus minus is written over there. Here, plus minus is not written. I am writing it as plus and minus as per the direction of current. High potential to low potential. Again, plus and minus is written over there. So when, remember one point, when you are applying the KVL, you need to write the plus and minus in order to avoid any type of problem. So plus 20, this one, I covered this, plus 20, after that minus 10 I1, minus 90, then I will take the 40 ohm resistance. I1 current is flowing in this 40 ohm resistor. So minus 40 into I1. This is the Ohm's law. We can say I into R. V is equal to I, or obviously we have to use the Ohm's law also. Ohm's law, everyone knows that V is equal to IR. This is the mathematical statement. One more component is now left. So plus minus, I will take minus 2V2 is equals to 0. So if we know the fundamental of Kirchhoff voltage law, all the terms are in the unit of voltage. And check this is equal to 0. I am calling this equation number 1. This is equation number 1. So now there is dependent source also, and V2 value is also written over there. Check this, V2. So what can we write here? Another equation, V2 is equals to 10 into I1, because V is equal to I into R, current into resistance as per the Ohm's law. So V2 is equals to 10 I1. This is, we can say, the second equation. We are going to use this equation V2 is equals to 10 I1, and we can put in the equation number 1. Write it as put equation 2 in equation 1. So what will be the equation number 1? 20 minus 10 I1 minus 90 minus 40 I1 minus 2 into V2, 2 into 10 I1 is equals to 0. So on solving this, 70 I1 is equals to minus 10 I1 minus 40 I1 minus 10 into 2, 20. 20 I1, 70 I1 and minus 70. So I will write here minus 70 I1. So I1 will be minus 1 ampere. The value of I1 will be the minus 1 ampere as per this question. So we need to find the current across the resistances. How many resistance are there in this question? 10 ohm. So current through the 10 ohm and the current through the 40 ohm resistance will be the same, minus 1 ampere as per the direction taken. This particular question. This is the basic single loop or single mesh question. Now talk about the super mesh condition. So super mesh condition occurs when an ideal current source is present in between the two mesh. So just now we discussed earlier what is mesh. Everyone knows what is mesh. In between the two mesh, Let's take an example. In this particular circuit, this example is applicable to the super mesh because this is first mesh, this is second mesh, and in between the two mesh, there is current source, an ideal current source of 5 ampere. So this is the super mesh condition. We can't apply the pure KVL here because we don't know the value of voltage across the current source. So we need to use the KCL also. Apart from KVL plus Ohm's law, we need to use the KCL in the super mesh technique. Let's solve this question. Calculate the current across all the resistances. How many resistances are there? 5 ohm resistance, and again second one is also the 5 ohm resistances. So we need to find out the current to both the 5 ohm resistances. So let's using mesh analysis. So first of all, it is written mesh analysis. We need to check whether this question is for the super mesh or simple mesh. So this question is, let's count the number of mesh. This is I1, assuming it as the clockwise direction. Second mesh also, assuming it as the clockwise direction. So we can write there are two mesh. How many mesh in this question? Two mesh. So we are unable to apply the KVL. We can apply KVL here across. So how to apply KVL? We will be unable to apply KVL in the mesh 1 and mesh 2 separately. So I'm writing here, I'm applying KVL at mesh outer loop because we are unable to apply the mesh. We are unable to apply the KVL in the mesh 1 and 2 separately because we don't know the voltage across the 5 ampere current source. So what is the alternative? Apply the KVL across the outer loop. Check this one, outer loop. So apply KVL at the outer loop. Apply KVL at the outer loop. So how to apply KVL? Just we discussed earlier. Plus minus is written over there. Again write it as plus minus. Again write it as plus minus as per direction. So I am taking the outer loop. So plus 5 volt minus 5 into I1 current. In this 5 ohm resistance, I1 current is flowing as per our discussion. We assumed it as I1 current, and in this mesh, there will be I2 current. So 5 volt, I taken here. This 5 ohm resistance also I used here. And now this one, I'm taking, remember, I'm taking the outer loop. I'm taking the outer loop for the KVL. So 5 volt minus 5 I1 minus 5 into I2 is equals to 0. We know that what is KVL, Kirchhoff voltage law, summation of voltage across the loop is 0. So this is voltage 5 volt, 5 into I1. This is again the voltage according to the Ohm's law, V is equal to IR. This is again Ohm's law, V is equal to I into R. So now this is equation 1. We have to stop here. Now how to use another equation in from this circuit. So this is the super mesh. Earlier we discussed that this question is super mesh because 5 ampere current source is coming in between the mesh 1 and 2. I'm showing again. Super mesh condition is when an ideal current source is present in between the two mesh. We need to use the KCL also. Remember this point, we need to use the KCL also. So now I will going to use the KCL. I1 current is flowing in this direction. I1, check this. 5 ampere is also coming in this direction. So I2 value will be the I1 plus 5 ampere. I have used here KCL, using KCL at node Vx, let's say. What will be the KCL? Very simple. I1 plus 5 ampere is equals to I2. We got the second equation. Now on solving equation 1 and 2, on solving equation 1 and 2, we can get the values of current. I1 is equals to minus 2 ampere and the other mesh current I2 is equals to 3 ampere. We got the value of both the two mesh. I1 current is the resistance across current across the resistance. I2 current is also the current across the 5 ohm resistance. This is the answer. So this was the question for super mesh condition. So mesh analysis is very simple. Mesh analysis is very simple. We need to follow some rules. Again, I am going to mark it as identify the total number of mesh. First of all, identify the total number of mesh, count 1 or 2 mesh or 3 mesh, assign the current direction for each mesh, assign the current direction, either clockwise or anti-clockwise. Develop the KVL equation. Develop the KVL equation for each mesh, and by solving KVL equations, mesh current can be identified. So remember once again the point, if you have to mark plus and minus, you have to mark the polarity plus minus everywhere. If it is not given and according to condition, you need to mark the plus and minus polarity mark. So super mesh condition also we discuss. Similarly, we can solve the 3 mesh question also. 1, 2, and 3. In this particular circuit, there are circuit number 3. There are 3 mesh. We can solve this circuit also with the help of 3 equations. The references I taken, first one is Van Valkenburg network analysis. The second, Sudhakar Shammohan, circuits and the network. Thank you for listening this lecture.